So when was the last time you heard someone speaking Latin? Has it been a while? Well, maybe if you go to Mass. You can still hear a Mass in Latin. But in day-to-day living, never. You don't go into McDonald's and hear anybody ordering in Latin. But the ancient tongue of Latin is still there, lurking under the covers. You still hear the echoes of Latin in our modern languages, because human language evolves over time. So Latin became Portuguese and Spanish and French and Italian and Romanian, the Romance languages, which then evolved into forms of English, and about 50% of our words derive from Latin. So computer languages have also evolved over time. The most ancient of computer languages would be pure machine code, ones and zeros, binary. But now you program in higher level languages like Java or HTML or Ruby on Rails or Python. But in the beginning, all was ones and zeros. This was incredibly difficult to work with. So people figured out you could represent 4 bits, any combination of ones and zeros for 4 places, with 1 hexadecimal character. So hex is kind of a shorthand for binary. So if you take 4 bits, you can come up with 16 combinations of 0 and 1. And there they are in the right-hand column under binary. And hexadecimal is base 16, which just happens to have 16 digits, 0 through F. So we can represent 4 binary digits with 1 hexadecimal digit. For example, instead of writing 1100 in binary, we could just write C in hex. So with computers, we don't normally work with 4 bits at a time. We work with 8 bits at a time, and 8 bits is 1 byte. You already know about bytes, megabytes, gigabytes, terabytes, but we can still represent this in hex if we break it down into 2 groups of 4. So if we take this side, we represent this in hex with a 3. If we take the other side, we can represent that in hex with a 5. So one more thing to remember. Remember, we had 4 bits could be combined 16 different ways. So this side over here can have 16 possible combinations. But these 4 bits over here can also have 16 possible combinations. So if you take them together, 8 bits can have 16 times 16 or 256 possible combinations. So now that we know what hex is, the question we started with was, where do you see this ancient tongue of hex anymore? And the answer is not too many places. One place I found was colors. Let's say you're building a new website, or you want to paint your living room and you're looking for a nice color scheme. You might go out and Google color palette. Click on this guy. Oh, here's some nice colors. So let's say we like this one of all times and places. Nice blue, nice yellow. If you click down, you look at one of these colors. Aha! Hex. So here we have 3 nice colors, and each one of them has a hex value and something called an RGB value. Looks like 3 numbers. So the question is, how do we get from those numbers to this color? So as it turns out, RGB stands for red, green, blue, the 3 primary colors. And if you remember back to elementary school art class, you can make any other color from some combination of these 3 colors. So what if we take these 3 colors and represent each with 1 byte in the computer? Let's see what we can get. So let's do a little Googling. Let's see, we're going to look for hex colors. Let's try this one. So here we go. So let's just take one of the channels. Let's take the red channel. So we know with 1 byte we can represent 256 different values. So we can go from 0 to 255 represent that many different shades of red. So anywhere from black, which has no red in it, all the way down to the reddest red. So if you look over here on the right, you see the RGB. So the first number would be the red value. So 0, 8, 16. This is only showing you every eighth one, not all 256. So from 0 to 255, which is bright red. So if you put all three color channels together, you can actually make any color you want. Up to 16 million colors. 256 times 256 times 256 is about 16 million. So let's go back to our original example and break that down. So here's a nice shade of blue we were working with. So now we know if you take 109 for the red channel, 177 for the green channel, and 180 for the blue channel, you come up with this shade of blue. Or if you want to speak hex, 6D for the red channel, B1 for the green channel, and B4 for the blue channel. So let's just check that B4 number, make sure B4 actually turns into 180. So here's a nice converter. So let's plug in our hexadecimal number for the blue channel, which is B4. Yep, B4 in hexadecimal is 180 in decimal, and that's the binary number you would see for 1 byte worth of data. So hex lives. So do your part to keep the ancient languages alive. Next time you're sitting in a McDonald's and you want to update your Facebook status to tell all your friends what you're doing, post this.